Power supply wattage. A watt is a unit of electrical power equivalent to 1 volt ampere or amp. So we say amp, which is short for ampere. And then total wattage needs are based on adding the power required for each device plus more for startup. So like in the case of a refrigerator or like fluorescent lights, we've all heard it's better to leave the fluorescent lights on versus turning them on and off every 5 minutes, right? If you're gonna walk out and you're gonna eat an ice cream and then you're gonna come back in 5 minutes and get another ice cream, just leave the fluorescent lights on, because to start them takes an incredible amount of voltage. And it also, the kick to start a fluorescent light is a massive amount of voltage versus just running. It uses a lot less power to let them run relatively, right? So that's why in most office buildings, they just leave them on, because they figure we're gonna use less power than turning them on and off all the time. And plus, you have breakdowns when that happens. You're wearing out the starters, the capacitors that start them and stuff like that. They use a massive amount of voltage to start fluorescent lights. So, so for starting up drives and things like that, it takes a lot of power. So like a refrigerator in your house, to kick that compressor on requires a massive amount of power. So a lot of times when your air conditioner breaks on your house, same thing for the air conditioner, right? It's just a capacitor. It's a $4 or $12 part, depending on the air conditioner you have. And then that capacitor goes out more frequently than any other component if it's aging. And once you replace the capacitor, you can look out there, it'll be bulged. So it's perfectly round when they're good, and then when they blow, they kind of bulge out. Instead of, they just kind of bulge. Inside the stuff blows. And so that's gonna cause it to malfunction. So it can no longer provide the voltage needed to kick that compressor on to get it started. But once it's started, you don't need that extra voltage, right? It's just the initial kick to get it going. So every time these little motors start up, they use a lot of power. So you need a little bit extra padding there. So if you have 4 disk drives in your computer, plus the power supply, plus the motherboard, plus a video card, you've got to add up all the power consumption, and then you got to give it some extra for all of those starting. And if you try to start all of them at the same time, you'll blow your power supply, right? So they start up slowly. They spin up now. The newer ones, they don't start cold turkey like that. They slowly spin up. So we don't have that initial suck of current, which will short out your power supply and blow it up. So that's why sometimes when your computer's running for weeks and years, and then all of a sudden you turn it off to go clean it, it won't restart, because all the power suck all at once from the power supply will blow it up. So it can handle it for a short time. Like I said, the peaks, it can handle the peak power burst for a few times. It'll tolerate it, but if you do it too much, it'll burn it out. And you're probably just blowing a capacitor inside of it, which is a 2-cent part, but unless you know what you're doing, you can't open it up and fix it, right? It's expensive. So general use computers require 130 to 205 watts. That's very small nowadays. Our computers nowadays, if you don't have an 800 watt power supply, you're probably pushing it. Servers and high performance workstations require 350 to 500 watts. That's back in the Pentium 2 days, right? Today, an 800 watt power supply is small in a desktop today. So power connectors, we have a P8 and P9 on the AT connector, and we have it on the motherboard there, and then we have an ATX connector. So we have an AT and an ATX. So they just kind of had 2 things, and now you have 1, and then there's a little extender, depending on the kind of motherboard you have today. So connections to peripheral hardware, we have a Molex connector and a mini connector. So everything's getting shrunk down today, so we have these mini connectors. Extenders and splitters, we have an extender that lengthens the reach of a power connector. So if it just won't physically reach, we can get an extender so that it gets longer, right? We add another few inches to the connector. A splitter increases the number of connections, but also you have to make sure that you don't split it too many times so that that thing no longer has enough power to feed all of those devices you have connected to it. Power failures. Power failures can have internal or external causes. External failures, which are more common, include surges, spikes, sags, brownouts, and blackouts. Surges are when you have a surge of power, and then you have a spike, just one quick high voltage spike or current spike. And a surge is where it comes up and stays high for a little while and then goes down. A spike is just real quick. And then a sag is where it sags down and then comes back up. And then a brownout is when it, so a sag is the opposite of a spike, right? It's when the voltage drops. And then a brownout is when it stays down and comes back up. So a surge and a spike, or a surge and a brownout, I'm sorry, a surge and a sag, and then a spike, no, it's a spike and a sag, a surge and a brownout. So sorry, but that's a surge and a brownout, a spike and a sag, and then you have blackouts where the power just goes out, and that can cause your gear to fail as well. Power protection devices, we have a surge suppressor, which will suppress surges and filters the effects of voltage, spikes, and surges, and that kind of smooths out the power variations. And an uninterruptible power supply, which is an inline battery backup, which we've talked about all this now. Power supply problems. So problems with the power supplies. So we have a possible problem here. We have possible power supply failure. The computer will no longer boot up. So the action is to check the power source and plugs, make sure all the plugs, make sure they didn't vibrate loose or something or to get pulled loose. Replace the power supply. Those are your two options. And then intermittent power failures. We want to include a test of the power supply in your troubleshooting process. So you may have a capacitor that's burst, but it's still connecting enough to work, but then sometimes it won't connect. And then we have persistent power problems, where it's just always malfunctioning. So just try installing a UPS for that kind of thing. And for our chapter summary, the AT style power supply is used for older motherboards, and the ATX style power supply is used for newer motherboards. So AT and ATX. X is the newer one. Peripheral devices use a Molex connector and mini connector. And different types of power failures can cause different problems and can damage computer equipment. Surge suppressors and UPS devices can protect computer equipment.